Welcome to our multi-threading in .NET video tutorial. We reached the final step in our tutorial and we are going to examine the code at runtime. I have already set up a couple of breakpoints so we can focus on more interesting parts of the code, and we're ready to start. I just remind you from the previous presentations in part 2 that we start our thread by clicking the OK button. Then we slow down the thread with the first click on cancel button. The second click on that button stops the thread, and there's also a third click on it that will clean the background of our home button. So now we're gonna click on our OK button to start the background thread or child thread, and this is gonna take us to a start color changer method that will initiate the thread. First, we need to create an object or an instance of the CLS threaded class. We're going to use two arguments that are essentially pointers to our local methods. The code for those methods is located within our main thread. Then we're going to use that object and place it on a new thread with the address of worker method from that instance being passed to the thread as the starting procedure. I set up another breakpoint in the new constructor of our CLS threaded class so we can look at what's happening here. Now we have those two pointers from the main thread. They're being assigned to local values of type delegate. One is a thread update, thread completed for the other one. They are being assigned the values from those pointers, and the pointers, as we can see, they point to a method. One of them is void, meaning it's a sub, and the second one is a method with the integer 32 return value. That's a function. So those values have been initiated. Now we're going to initialize some of the local variables that we'll use throughout the processing, and we're going to jump right back to our start color changer. At this point, our thread had been created and initialized, but it's still not running, and we can see that if we look at the properties, the flag is alive is still false. That is going to change once we call the method start on it, and we're going to do just that. And now, because that start method was called, the thread knows where the sub is located for the start point, and it comes here to the worker procedure and initializes some of the local variables, and then goes into that, in our case, infinite loop that's going to do the processing and communicate back and forth between the main thread and our child thread. To see how our delegates work, I'm going to activate the breakpoints that I have in update remote and update local, and I'm going to let the code execute, and we're going to come to the update remote, and as you're going to see, we go through this process of evaluation for the invoke required, and in our case, if I take a mouse over, it says it's true, meaning to execute, the program has to invoke the method that had been specified here. So we create a delegate of the type that is the same type as we specified for that function, and we're gonna invoke it. Because I set up a breakpoint in the local, we're gonna see how it executes there too. And here we are in update local. It's gonna come to return value, and it's gonna return straight to remote update. And if you saw what happened, we did not go to the child thread we came back with the next call from the child thread. I'm gonna deactivate those 2 breakpoints right now so the execution can continue through it. And as you can see, the child thread is working and is changing the color of our button. Now we're gonna see how we communicate with the child thread to slow down by pressing this button. I press the button, I come to the breakpoint, but I also want to activate some of the breakpoints in a worker thread so we can see how the worker procedure responds to our actions on the main thread bot side. So now we're here in the worker, which is our child thread, and our state is set up to slow down. I state is 5, th result slow down is 5, and because of it, that extra statement right after that is being executed, and that statement is threading thread sleep in 50 milliseconds. That means that thread is going to stay inactive for 50 milliseconds, and that is going to effectively slow down our execution. I'm going to deactivate those 2 breakpoints and continue with the gradual slow change. I'm gonna click the cancel button again to stop the thread, and we're gonna follow the execution on the stop thread. So I hit the button, we come to the click button method, and our cancel thread is false, but because we clicked on it, it's gonna set it to true, and based on that flag is gonna respond to the child thread. And I'm gonna activate those 2 breakpoints again. So we hit the continue, and now we're in the local, update local, and if you look at those values, the B cancel is set to true, so our return value is going to be cancelled. And let's activate those 2 on the worker side. We didn't stop there, but we can see that now our complete delegate had been called. Because this method can be called from either within the main thread or the outside thread, the invoking process starts again, and in our case that invoke required is set to true. We're gonna continue through here, and we're gonna come to a completed local. The reason why I came here, I wanted to show you that that thread, even though we are at the end of the execution, that thread is still alive. I'm gonna open the output window and walk through it, and I put the debug statement that says sub th complete local, and the thread is alive. I'm gonna close this window, and as you can see, there is an object and is alive, and it's set to true because that thread is still alive at this point. Gonna step over, and now our main thread is running the program. The background thread completed, so should be finished. Now we're gonna click the X for the 3rd time, and this is supposed to clean the back of this button, but it's gonna execute the code slightly differently. When I hit it, our th update underscore remote method is gonna be called from within our main thread, because our background thread is actually finished and is no longer active. But because the call comes from the local thread, we come here, invoke required is set to no, and the execution is not gonna go through creating the delegate to call the local equivalent, but instead is gonna call that method directly. So now this is gonna execute as usual. It's gonna set a color because the color that I set is just transparent. Now button is clean and we are done. There is one more thing that I wanted to show you, and this is very important when you starting to do background threads. Make sure that when you finished, you clean up the threads, because leaving them behind, it can actually keep the application running even though your main thread released and is finished. To do that, I set up an extra procedure here, and if you see here, bCancel thread is setting to true if the background thread was still running. In our case, it would signal that thread that is no longer required, and it would come to a complete stop after our application is closing. And we are done. And this is the end of our presentation. Hopefully you stayed with us through all 3 parts and you enjoyed it. I hope you learned something from it, and please come see us again.